Well, hello again everybody. Well, it looks like this month we do seem to have a little bit of a soldering iron theme going on, don't we? Well, of course I say soldering iron, but it's actually not a soldering iron, it's actually a heated desoldering gun, so it's a desoldering iron, isn't it? Or, well, I suppose we should actually call it a desoldering pump. And I think I'd probably be right in saying that this is pretty much the cheapest powered desoldering pump that you can buy. I think I bought this on Amazon for about £12 delivered, but you can actually get it on eBay for I think about £9 or even less. And of course, when you kind of get at that type of price, it's amazing that anybody can make it for that little money, isn't it? So I don't know how good it will be. Let's find out. So we've got some instructions on the back here. I could read them, but it's more fun to struggle, isn't it? So we won't bother with them. Let's debox it. Well, here's a typical desoldering pump. Now, I'm sure that most of you are familiar with these, and you've probably all got one at home. So effectively, what we have here is it's a metal-bodied syringe. And inside our syringe there's a plunger that's got a rubber seal on it, and that plunger is pushed forwards by this lever here. So you push it forward and the lever clicks into place. It gets held by the button, but as you actually push this lever forward, it actually gets the plunger is actually being forced back against the button by a spring. So basically when you push the lever forward, it's compressing a spring, so if you release it, it springs back. But we push it all the way in, locks into place. So of course what you need to do is when you want to desolder something, you take your normal soldering iron, you heat up the solder, and then you very quickly do a bit of a changeover. You take your soldering iron off, you put the pump onto its over the component leg there, you press the button, oops, and the thing jumps out your hand. Try again. Of course, we're just going to go ahead and edit that out of the video, and we'll have another go. So here's an old circuit board that I found, got no idea what this was. So the way that you use these traditional desoldering pumps is, let's have a go at this LED here. You actually heat up the solder using a conventional soldering iron, and then what you want to do is you do a little bit of a rapid changeover whilst applying the heat here. You put the soldering iron nozzle above the component leg and press the button. And Bob's your uncle, out comes the component, and usually it probably goes easier than that. Let's have another go, because I made a bit of a cock of that, didn't I? So heat up the solder, put the pump over the top of the component leg and press the button. And in theory it just sucks all the solder off. It sucks it into the body of the desoldering tool. And usually you've got to have a couple of goes at this in theory. Will that come out? Yes, it will. So there you go. But what's actually interesting about this desoldering tool is we've got the same pump here, and you can see, you know, the things really do look very similar. You press the plunger down, you press the button, and the plunger shoots back. Just the same as our traditional desoldering pump. But what this actually does is, you can see that, I suppose it's a bit of a giveaway, it's got a mains plug on it. So what this actually does, it combines the desoldering pump with a soldering iron. So this end here gets red hot, and well, just like a soldering iron does. And the actual, rather than being a conventional soldering iron tip here, which is solid, that this tip has got a hole in the middle. So what you use is you use the soldering iron part to heat up the solder, and then when you actually press the button, it sucks up all the molten solder again into the body of this thing. Now, I've heard fairly mixed reviews about these things. Some people say that they do actually work quite well, but they tend to be a little bit fragile, especially the heating elements. They're a bit hit and miss. So I think a few people who've used these things, they say they almost like buy two at a free at a go, and they kind of treat them as being almost disposable, because I guess the quality of the manufacturing isn't exactly top notch. But again, for £12 and for occasional use, I wouldn't complain too much about that. So yeah, let's give this one a go. Of course, it doesn't come with a soldering iron stand, so that's another fail. So we'll have to go and find a stand to put it on. And I think what we'll do first of all is we'll just do the standard kind of soldering iron test. So let's see how quickly it gets up to temperature, how much power it uses, and at what temperature it does actually get up to. So let's go ahead and do that. Just break off a little piece of solder and we'll wrap that round there. And it's time for the big switch on. 1, 2, 3, on. And our mains voltage today, well, it's actually quite low for once. It's only 241 volts. How much power is this soldering iron consuming? So let's have a look at that. It's drawing 34 watts. So we've got a 34 watt heating element here. So we're coming up to our first minute now, and our soldering iron, it's obviously getting hot, but it's not melted the solder yet. Let's leave it going. Oh, I can see smoke coming off the heating element. Now it's not actually coming from the front, it's actually coming from the back of it. Let's hope that that's not too bad a sign. Oh, okay, so that was 1 minute and 40 seconds it took to actually melt our solder. So let's leave this soldering iron on for a little while, and we'll just see what final operating temperature it reaches. Well, we're about 4.5 minutes in, and I'm just going to have to move away from my desk and go and open a window, because my workshop here does seem to be filling with quite a lot of quite horrible, acrid, chemical smelling smoke. So yeah, I'm going to go and open a window before I die. So we have to say that really is quite impressive, isn't it? They've not only managed to build a desoldering tool, they've managed to make a smoke machine at the same time, which is certainly something special. Okay, we're about 8 minutes in now, and you can see I've gone ahead and I've just stuffed my thermocouple probe actually into the nozzle of the desoldering tool, and the temperature here, it's 437 degrees. I don't think that's too bad. Of course, this soldering iron isn't regulated, and because it's an unregulated soldering iron, it's always going to run on the hot side. Well, for the most part, it does actually look as though most of the smoke has now actually burnt off the heating element. So I'm guessing that's just because it's you know, it's a brand new iron. It's maybe got oils or grease, something used in the manufacturing process, and that's gone ahead and that's just burnt off now. It's just got a little bit of smoke coming off it. So that's certainly an improvement. So our desoldering tool here, it's come up to temperature, and just picking the thing up, I've got to admit, it actually feels quite comfortable in the hand. Of course, the fact that it's got a lead on the back of it, kind of, and it's a mains lead, it does kind of tug on the soldering iron a little bit. The actual handpiece itself, it actually weighs pretty much nothing. It's very lightweight, so I don't mind that at all. It feels quite plasticky, but it doesn't feel as though it's going to come apart in my hand. It does feel as though it's man enough for the job. Now the end of it here, yeah, actually that is quite hot. So if I actually slide my fingers right there, ow, I can't actually keep my hand there. So it looks like the insulation leaves a little bit to be desired at the very end of the soldering iron handle. Now of course you probably don't want to put your hand that close up. I'm just wondering what the best way is to actually hold this. So you really want to operate, I guess, the plunger with my thumb there. Well, ergonomically, that works. My fingers are away from the hot end here, but it's not going to burn you, but you could certainly, I can't keep my finger on the end here. It's hot to the touch, but yeah, I don't think it would actually burn you, but you can't keep your finger on there, so it's a little bit hot. But ergonomically, yeah, it works in my hand. I've got no complaint with that. Again, not used it before. Let's see if we can find something to remove. Now these components have got an awful lot of solder on some of them, so we might struggle to get them off, and a lot of them have got the legs bent over as well, which always makes it a little bit more difficult. So let's just have a go for the first time. Well, that certainly did remove the solder. Don't think it did a perfect job that time. Give it a bit of a wiggle. Yeah, didn't do a perfect job that time. Unfortunately, when it comes to soldering iron sucker tips, you really want a tip which is just a little bit larger than the component leg. Now this is a lot larger, so we're going to be leaking a lot of the vacuum from around the actual nozzle end. Okay, so I think it took a few attempts there. Is that going to come off? Yeah, so we just took a little 3-pin header off there, and well, yeah, it did it. Okay, we've got some pads on here that have got some really big globs of soldering, so what I'm going to do is I'll bring you in and you can have a look at those. Okay, I think I've just gone ahead and moved a little wire link there, so that was okay. Got a really big glob of solder here, let's see if it melts that. Yeah, certainly got plenty of thermal mass. You see we've got a huge glob of solder here melted. Let's see if we can suck all that melted solder up now. Well, it did actually suck most of it up. Okay, so I've got another equally big glob of solder at this side. Is it going to heat that up? Can we use it as a crowbar? That's always a good test for a desoldering tool, isn't it? Yep, we can. Okay, there's another pad, let's try that. Well, as you can see here, we've got a 14-pin dill header, so let's go ahead and see if we can remove that. I guess one advantage of having such a big tip as this is it doesn't get blocked quite as easily as a lot of desoldering tools I've used does. Hasn't even got slightly blocked once yet. So again, just using this, the nozzle is actually so big I can actually get it on kind of 2 pins at once, which isn't necessarily the best thing. Well, I've got to admit, doing that didn't feel particularly pleasant. Has this come loose? Yes, it has done the job. This appliance is not intended for use by persons, including children, with reduced physical, sensory or mental capabilities or lack of experience and knowledge. Well, that buggers me up, doesn't it? So we've had our desoldering tool now switched on for about 25 minutes. Now I couldn't help noticing when I just tried to remove that last dual inline socket that the body was starting to get uncomfortably warm. So it's not so bad at this end, but as I start to just move my fingers along, that is now getting quite hot to the touch. That is even hotter. Ow, and that is above 50 degrees. I can always tell, you can tell 50 degrees because 50 degrees is a temperature where you can put your finger on it. It doesn't burn you, but you don't want to keep it there. And I suspect that, this end is probably about 65, 70 degrees. So let's just see if we can do a little bit of a temperature profile on that. So the back end here is, well, probably around background, 26 degrees. Let's move further forward just to the end of the label. That's come up to 30 degrees now. Now we're up to 35. Let's get a bit closer. Now the temperature's jumped up quite a lot now. We're up to 48 degrees here. So there you go, 103, 108, still climbing, 101. So basically where this black guard joins the yellow body here, we're at 100 degrees, 101 degrees. So I'm suspecting that what we're actually seeing there, the heating element probably just comes through, or certainly there'll be a tube in here which this molten solder gets sucked into, and I suspect that that's a metal tube and it comes through into the handle area here, and there's just not enough material around here. There's not enough of an air gap to actually keep this end of the soldering iron cool, so that's actually quite unpleasant. That I mean, my finger's not sticking to it, but that is genuinely quite painful now. I certainly, if I was to try to hold my hand there, I would definitely be inflicting burns on myself. That's quite uncomfortable. Well, I think unfortunately, due to the very high operating temperature of this handle here, I think that's going to be a cross firmly in the fail box, I'm afraid. So what I'm going to do is let's switch this off. We'll let it cool down, and let's see where all that soldered goop that we've sucked up has actually gone to. So after unplugging our desoldering pump, it's taken about 20 minutes to cool right down, and well, it's actually completely cold now. And according to quite a few different people that I've spoken to, they've all had a lot of difficulties in actually removing the I don't know, the solder dustbin, this little repository. When the solder gets sucked up, it gets pulled into this plastic chamber here, and some people have just said that it's really hard to get these apart. So reading online about it and looking at a few other YouTubers' videos, a few people have also said the easiest way to do it is to press the plunger in first. So we're going to take their advice. I'm going to put my thumb on the back of it and just push forward and pull, and yeah, that's really deceptively easy. So as you know, my previous complaint was how hot the front of our desoldering pump gets, and I think there's a reason for that if we actually just take the little solder bin away. So we'll take that away, and you can actually see there's kind of a metal pipe here. What's that made out of? Is it stainless steel? I've got a magnet. Oh no, my magnet sticks to that, so that's a piece of mild steel. So this this is where this tube here, which runs from the tip of the soldering iron right to the back to the solder reservoir, this is the path that our hot solder takes, and we can kind of demonstrate that. So here, let's pretend this piece of red wire is a piece of molten solder, so it's going to get sucked up by the tip. It's going to go down this tube, he said. Go on, get down there. It's going to go past the heating element, and it's going to come out of here and go into our reservoir with all this other solder. So that's the path it takes. But of course, this piece of metal here has to be above the molten point of solder, because if it wasn't above the melting point, this would just well, it'd be solid. It would just jam. The solder would solidify, and it wouldn't be able to suck a vacuum through. It wouldn't be able to pull solder through it, would it? So the end of this tube is up around, I suspect it's probably around 400 degrees, maybe 450, and because it's in such close proximity to this piece of plastic, literally just millimeters away, just air convection means that it's going to get very hot. You know, the tube is hot and it's very close to this piece of plastic, and just the heat rising, just the convection is actually, and the radiant heat on this piece of plastic is going to heat it up. So really, this piece of plastic here is much too thin, and it doesn't have enough thermal insulation around it. You could almost do with putting some kind of, you know, a silicone sleeve over it or something like that. But that explains why the handle gets so hot anyway. Now, another complaint that I've heard is that this collection tube doesn't form a good vacuum, because some people have said there is no seal on it. Well, looking down there, there is a seal. There is actually a rubber seal down there. So this, the end of this collecting tube is kind of dimpled, and that does press against the rubber seal. I can actually feel it compressing the rubber. Now, there isn't a seal at this end, but of course it doesn't need to be, because the seal is made up of our plunger here. So we don't need a seal at both ends. We only need a seal at the front, and we've got one. So again, I'm not complaining about that. It's doing its job. So our mains cable comes into the soldering pump at the back here, and it looks like there's kind of a little groove here, which I can see on this side as well. So I'm guessing that the wires from this PVC flex, they may be going to some kind of a junction. Can we just open this up and take a look? I'm just feeling a bit nosy. Let's have a look. Now, these two white wires here, these form the live and neutral that are going to our heating element, and as you may be able to see, I can certainly see it, they are wrapped in that heat-proof kind of, I think it's probably something like glass fibre, something like that, but these are wrapped in a high temperature insulation so it won't melt, and they've actually just been, looks like they're just soldered onto the incoming mains lead, and it looks like we have also got an earth on there, so that's nice to see that. Hopefully our heating element has got an earth on it. We will test that in a minute. Now, apart from the slight overheating of the handle, I think the big thing that really lets this soldering iron down is actually this tip here. This is the tip that presses against the PCB circuit board, the pad, and it's just much too big. I don't know why anybody would put a tip on of this size. You could suck nails up with this tip. I wonder if we can actually measure exactly how big it is. How big? What's that? Okay, that doesn't quite fit. Do any of these screwdrivers fit? Okay, that one kind of just fits. Let me take a measurement off that. 1.98, so I suspect that this is actually slightly bigger than 2mm because we've got a bit of wibble wobble there. So I found a much bigger circuit board here, and the reason I found this is because it's got some actual quite large pads on it for things like this EMC filter. So I thought we could actually have a go at unsoldering some of these components, because I think that with the very big nozzle, the very big tip on this desoldering pump, I think it'll do much better on these bigger pads than it will on the small ones. So let's give it a test. Now, in all fairness, this isn't such an easy test because these boards are covered in what they call conformal coating, so we're going to have to burn that off to actually get to the connection. Okay, it had no trouble doing that actually, so let's have a go with that. Well, it looks to have got all the solder off. Can we just pull our filter off now? Okay, got that off, no problem. Well, as we just witnessed there, this desoldering pump certainly didn't seem to have any problems taking out that larger EMC filter, so it works much better on components that have bigger legs, and I'm not surprised by that because it's all down to the size of the hole here in the nozzle. And I was just actually trying to figure out how to take this nozzle off, and at first I thought that you had to undo them two screws. There's a screw on each side, so I tried undoing that, that didn't work. Tried pulling on it, that didn't work, and then I kind of just twisted it and found out that it actually just unscrews. So I wonder what the tip is made out of. Okay, so the tip is stainless steel, so that's good. That will mean that it will last a little bit longer rather than being made out of mild steel, for example. I guess they've chosen stainless steel because it's probably slightly less prone to, you know, kind of the corrosion being caused by the heat and maybe the flux on the solder. So yeah, there's nothing wrong with the tip on there. The only problem with it is it's just such a big tip, it's just too large. But now I've found out how to remove it, what I think I'll do is I'm just going to have a quick Google online to see if it's possible to buy smaller tips for this, because I think if you could buy a smaller tip, it would make all the difference. Okay, well, I've just been searching online, and replacement tips are actually available for this desoldering pump for various places, including eBay, Farnell and CPC, to name just a few, and they're commonly available and they are cheap. But the problem is that unfortunately they're all 2mm, which is just the same size as this one is. So although there are replacement tips available, because you will wear them out in use, they're all 2mm. So I'm afraid that's another tick in the fail box, because the size of tip on here it's actually seriously affecting the operation of this desoldering pump. It would work an awful lot better if the tip size was smaller, because you actually want a tip that's just slightly larger than the component leg. If it's too small, you won't be able to get it over the component leg, but if it's too big, it's going to actually leak an awful lot of vacuum around the pad rather than trying to suck the solder through the hole that the component lead is placed through. So yeah, that's a little bit of a shame actually, because it does detract from the performance of the desoldering pump. Well, I thought the next thing we could do is just to try some safety tests on this thing. So I'm just going to do the typical type pat test. But before we do that, let's just check what the fuse rating is in here. Hopefully it's got a fairly low ampage fuse, so let's just check that. Okay, and it has got a 3 amp fuse, and well, if we believe it, it is of good quality. It's actually a Buzzman manufactured fuse, so there's absolutely nothing wrong with that, and it's got printed on it BS 1362. You know, it looks like a proper pucker job, that, so no complaints there. So just taking a look at the mains plug that it comes with, it does look like quite a heavy and substantially moulded plastic plug. It's got an inbuilt strain relief. It's got both the live and the neutral pins insulated. They're shrouded, which is a problem with some plugs that are made to copy the British plugs in China. And of course, quite rightly, the earth pin doesn't have any sleeving on it, which is also correct. Now, it has got various approvals stamped into the moulding. I don't claim to actually know if any of these are correct or the right thing, but just looking at it, I certainly don't suspect that there's anything wrong with it. It looks fine. It looks good quality. So as you can see, we've gone ahead and we've got the Clare test set up on the bench. We've got the earth lead from the Clare tester just clipped onto the nozzle end here. Let's plug in the desoldering pump. Now, I've got the Clare tester set to the 500 volts RMS range, so that's going to carry out an insulation test to 500 volts, and it's going to be looking for an earth impedance of the cable of less than 0.5 ohms. So all I've got to do now is press the button. It says just lifting the lead off my legs. Press the button and we get 2 green lights, so that's a pass. And looking at the resistance here, that's less than 0.1 of an ohm, so that's good. Now, I had planned to actually cut the plug off this and strip some of the insulation back and have a look at the quality of the mains wiring, but I think based on the Clare test we don't actually need to do that, because the earth continuity, it was less than 0.1 of an ohm, so they must be using copper wire in here of reasonable quality. It does actually, again, it's got quality marks stamped on the side of the cable. That doesn't necessarily mean anything, but it has got them. I'm looking to see if I recognise any of the marks on it. Okay, well, it's got the VDE stamp on it, and it's also got the cross-sectional area, which is 0.5 millimeters square. And the cable doesn't feel like that horrible sticky cable that we've all had on cheap Chinese equipment. It does feel like quite a nice, I'm guessing it's PVC flex, but yeah, I don't suspect there's anything wrong with that. All good there. Now, it was one of my friends, Robert, that actually recommended this desoldering pump to me, because he bought one, and I've also spoken to other people who've given it rather mixed reviews. A lot of people report that this container is more or less impossible to remove, but again, I think we said that I haven't found any problems taking this one apart. Maybe they've changed the design of it. Certainly the vacuum seems quite powerful. It works. I actually think it works quite well. The only thing that's letting it down is the size of this tip. Certainly it would be good if you're trying to remove larger components. I think you may struggle for very small stuff, but it does work, and I think it probably works better than a conventional non-heated desoldering tool. So I'm going to give it marks for that. I'm a little bit of a brand snob. I like my Pace equipment. My Pace desoldering pump, I think, cost around £1,500. This one cost £12. You can get it for about £6 online. On that basis, because it was so cheap, I was absolutely determined to hate it and give it a bad review. But I'm not going to do that. For the money, it's exceptional value. It seems to work. I don't know what the longevity will be of the heating element, but so far I've had it on for probably about 5 or 6 hours in total, which I'm sure you'll agree would be quite a lot of desoldering, and I've detected no problems with it. The build quality is adequate, so although it gets a bit of a thumbs down for getting a little bit hot to the touch here, I think that's also manageable. You just have to be a little bit careful, watch what you're doing, and overall, although it's got a couple of crosses in the fail box, I think overall this is actually a winner, so no complaints.